Hello and welcome to another video. Today we're going to be working on remove all adjacent duplicates in a string 2. And you're given a string s and an integer k, and a k duplicate removal consists of choosing k adjacent and equal letters from s and removing them, causing the left and right side of the deleted substring to concatenate together. We want to repeatedly make k duplicate removals on s until we no longer can, and then we return the final string after all such duplicate removals have been made. Okay. So in this first example, we have ABCD and k equals 2. So for ABCD, we have no duplicates together, so we would just return the original string. Okay. In the second example, so we have DEE, DBB, CCC, BDAA. And if you look, this CCC is a duplicate, right? So this is a duplicate, this is also a duplicate. So let's just start deleting some stuff. So it doesn't really matter which order you delete, but let's say we delete this, right? We delete these E's. And now our string is gonna look like, I'm gonna move this over here. Now string is gonna look like this. Now we also have these 3 C's, right? That we can delete. So let's delete that as well, these 3 C's. And now what do we have? So we actually have, whoops. Okay, so let's move that over here. So now we have DD, BBB, DAA. And these 3 B's can also be deleted, right? BBB can be deleted. So let's delete that. Let's move this over here. And now we have DDDAA, so we can actually delete these D's as well, and then we're stuck with AA at the end. So that's what we return. So you could see, like, initially you can only delete a few things, but once you delete some things, then some other things combine, and so that is going to be needed to know for future cases. Okay, let's finally look at the last one, and I think in this case, how do I want to do this? I guess I can write it. I guess it's okay. I'll just write it here. So we have PBB, CGG, TT, CIII, PP, OO, AAIS. And this time I'm actually just going to use the cursor. So we have 3 I's here, so we can delete those. Okay, now what else can we delete? Oh, so actually, sorry. I messed up there. So here k equals 2, so we can delete pairs. So we can delete this pair, we can delete this pair, we can delete 2 of the I's. It doesn't really matter which way. We can delete 2 P's, we can delete 2 O's, we can delete 2 I's. Sorry, this is 2 A's. Now we can delete 2 I's, we can delete 2 T's, and we can delete this, and we're stuck with PS now. So you could see, like, initially we couldn't delete some stuff, but afterwards we could, right? Like this C and this C, we couldn't delete them at first, but then we could. So we have to figure out not only, like, what things are next to each other to delete, but also when things get deleted, how do we deal with that case, right? Like, let's go back to this case right here, maybe. I think this was one of the best ones. So let's actually go through this. And let's try to get some intuition for how we could do this problem. So we have DEE, D, B, B, C, C, B, D, A, A. So you can see, like, here, the only thing you can delete here is technically this, I believe. Oh, no, there's actually a C here. So you can delete these E's, and you can delete these C's, and the order doesn't really matter. But then once you delete some stuff, some other stuff becomes available. So once you delete these C's, now you can delete these B's. You couldn't before. So we have to figure out, like, how do we do this efficiently? And as you can see, our constraint is 10 to the 5th, so we need, like, an n or n log n. Okay. Well, if you actually take a look, if we delete these C's, like, let's go through this in order, and then this will give us a lot more intuition on what we need to be doing. So instead of writing it just like this whole string, let's just write one letter at a time. Okay, so we're going to write D, E, E, E. Okay, we have 3 letters. We can delete that. So that part is pretty straightforward, right? We can just check for 3 letters, or whatever k letters is. Okay, that part is pretty straightforward. So we deleted that. Now we are over here. So we are going to write D, B, B, C, C, C. Okay, we have 3 letters in a row. Cool, let's delete that. So now we can delete that. Now we are over here. Then we write a B. Oh, we have 3 letters in a row again. Let's delete that. Okay. And let's delete this one. And then finally we have D, which we have 3 letters in a row. Let's delete all that. And now we have these 2 A's. So essentially, we need a way, if you go back, we need a way to figure out how to have, and this K can be really big, right? This K can be 10 to the 4th. So we can't just like check, oh, do we have 10 to the 4th letters in a row? We need some way of doing that, some way to update that. And there is actually a way to do that, and that's going to be with using a stack. So what we can actually do is, instead of saying, you know, how many letters in a row are there, we could just say, like, if we're pushing a letter on, like a D, and we have some other letter, we could just say, like, oh, we're pushing on a D. This was a D. And then we can also give every letter a count. So we can give every D a count. And then, like, if this had a count, like, like 7 or something, then it would be pretty straightforward to know what the count of this letter would be, right? This would just be, we can just check, like, oh, is this previous letter a D? Yes, it is. What's its count? And then we can just add 1, right? So let's just go through something like that, where we're going to store a letter and its count. And then we're going to just check what the counts are. So now, instead of storing just a letter, we're going to store the count. So we're going to start with this letter here. And we are going to change the colors just to make it a little bit easier. So we are going to store letters and counts. So for this D, we're going to say, like, is there a previous D? No, there's not. There's nothing here, right? And we're actually going to store this on a stack. So we'll just call this like stack. One big stack. Okay. So we're going to store D, and is there anything here? No, there isn't. So this count is going to be 1. Now we're going to store the E, and when we store the E, we're going to check the previous letter. It's not an E, so we're just going to store E with a 1. Now we are going to store E, and we're going to check. So we're at this E here, right? And then we need to check, like, what's the previous letter? It was an E. So if it was an E, let's just take whatever count that was and add 1. So that count's going to be 2. And now let's add another E. We're on this E here. And is the previous letter an E? Yes, it was. Okay, let's add 1 to the count. So actually, by the way, we can actually not need to store this. So before we store this, we can just say, like, if K is 3 and we're storing an E, we can say, oh, is the previous letter an E? Okay. What's its count? And if its count is K minus 1, then we know, like, this letter is going to go here, and then we're going to have enough to pop all of them. So we can just say, okay, instead of storing this one, let's just pop all of the E's off. And there is a slight optimization you can make. So the slight optimization you can make here is, instead of storing every letter with the count, what we can actually do here, so let me show you. So let's say for this K, this is 3. So when we store this E, this will be 1. Now for this E, instead of actually putting another E on, we could just say, what's the last letter? Oh, the last letter is an E. Instead of putting another E on, let's just update the count. So actually, when we put on this E, we'll just update this count to 2 instead of putting on another E. And then for this E, we can say, okay, what's the last letter? It's an E. What's its count? Oh, it's K minus 1. Okay, now we have enough to delete. So now we're actually going to delete this off the stack because we know we're going to have K iterations of it now. So we're going to delete this off the stack. And then we are going to put a D on. So when we put a D on, we're going to check the last letter and say, oh, it's a D. So instead of putting on a D again, we'll just update its count to 2. Okay, so now we are over here on this B. So we're going to put on a B. We're going to say, is the last letter a B? No, it wasn't. So we're going to put on a B with count 1. Then we're on this B, and we're going to say, is the last letter B? Yes, it was. Let's just update the count. Okay, now we're on the C. So the last letter was a B, it was not a C, so we're going to put it on C1. Then we are on this C, the last letter was a C, so we're going to update the count to 2. And then on this C, we're going to say the last letter was a C, and the count is K minus 1, which means we're going to have enough C's to pop them. So now let's just pop this here. So we're going to pop that. And now we are on this B. Was the last letter B? Yes, it was. Is its count K minus 1? Yes, it is. So now we can actually pop the B's as well. And now we have a D. So is the last letter D? Yes, it is. Is its count K minus 1? Yes, it is. So now we can pop the D as well. now we can get rid of that. And then we finally have 2 A's left, so we're going to put on an A with count 1. And then we're going to put on another A, and the last letter was an A. So we're going to just upgrade this count to a 2. And finally, our stack is this. And so at the end, we're going to have some letters with some counts, and then we can just build this up, right, into a string. So we can just say, like, let's just take every letter times its count and join all those together. So here we have A times 2 is the only thing in the stack, so our result will be AA. And that's how you do it. Use a stack and use a counter, and then you can just check for the count to be K, and every time the count is K, you can pop off the stack, and then finally you make this whole list comprehension. You know, you're going to have some letters with some counts, like let's say a B2 and so on, C2. You would just say like, okay, well, this is 2 A's, 2 B's, 2 C's. And you can join that together in O of n time. Okay, so now we have enough to code. So we're going to make a stack here. And let's just go through every single letter. So we can just say like for char in S. And then we can say if stack, because you want to check when you're comparing to the last character in the stack, because you don't want to have an out of bounds error. So you can say if stack and you can say char equals stack, and then we're going to compare it to the last element, and it's going to be at index 0, because we're going to have, for our stack, we're going to have the character and then the count. That's going to be our format for the stack. Okay, so if the character is that, then if stack -1, 1 equals k minus 1, then we can just pop. Otherwise, oh, this is screwed up indenting wise, so let's fix that. Okay, so we can pop. Otherwise, what we need to do is we need to increase the count, right? So it's going to be stack -1, 1 plus equals 1. Okay. So now, otherwise, we don't have a matching character, so we're simply just going to append that character. So it's going to be a stack.append, and then it's going to be character with a 1. Okay. So this is going to go through our stack, and then we're going to have some stack with, you know, our stack is going to look like a bunch of arrays of characters and counts. And so now we need to actually build all of that up. And so we can do a nice little list comprehension here where we can say return. We're going to join the stack. And the way we're going to join the stack is we can just say, so I think you can do this. You can do char 0 times char 1 for char in stack. And essentially what that's going to look like, if you think about it, is let's say we have a stack like this with just a couple characters. So let's say we have like A5, B4, and so on. Essentially what that's going to do is this char 0 times char 1. So for the example, for this case, for this A, it will say, okay, let's just take A times 5. And then in Python, that's going to give you 5 A's. So that'll give you like this part, and then this will give you 4 B's and so on. And then we're just going to join every single one of these that it's made, and that's going to be O of n time. Okay. And now we can try that out. So now let's see if we screwed anything up. Yeah, I guess we did. Let's see here. So what do we screw up here? Oh, so join takes, I think you need to do this. See if we screwed anything else up. Okay. Okay, let's take a look. So we actually do have a pretty efficient algorithm. And yeah, so let's go through the time and space complexity here. So for the time, we went through every single character and we appended them onto the stack, or we pushed them off or whatever. And then we also did this. So this is going to be O of n, because worst case scenario, you know, we push every character on and we push it off. That's O of n, and this string bill is also O of n. So that's going to be O of n. And for the space, so we did use a stack. So worst case scenario, every single character will be like unique, right? And then you push it onto the stack. like in this example, you'll have every single character with a count of 1, so that would be O of n. Yeah, so that's going to be it for this problem, I think. Yeah, the time space is O of n. Hopefully you liked it, and if you did, please like the video and subscribe to the channel. It helps grow it a lot. And I will see you in the next video, so thanks for watching.